Okay, Chapter 11 is an extension of Chapter 10 and 9. We're still doing hypothesis testing. We're still testing population means. Chapter 9 was one population against a constant. Chapter 10 were two populations. Well, if you have more than two, what do you do? And that's what Chapter 11 is about. If you have more than two populations and you're testing population means, then you need to use a different math technique called analysis of variance. And we calculate a different statistic called an F statistic. So the only thing we're going to focus on is something called one-way analysis of variance, ANOVA, A-N-O-V-A. ANOVA is what that is. And we're looking at testing multiple means, more than two means against each other. And we call these different levels treatments, but that's not that important. The most important thing is that we're comparing the treatment means. We're comparing means, and you can see it's more than two. And the technique we use is called analysis of variance, or you can say ANOVA. Here are the steps that we'll do. Our null hypothesis is that all of these means are equal to each other, and the alternative is at least two are different. So ANOVA does not tell you which one is better or worse. It just tells you that at least two are different than each other. So in one sense, it's a very strong test. It's a gatekeeping type test. But in another sense, it's a very weak test because it doesn't give you the final answer. We set our alpha. We calculate F. How are we going to calculate F? We're not going to do this by hand or calculator. We're going to use the data analysis add-in and use the ANOVA, which will also give us the p-value. From that, we'll have a conclusion. And here's the difference, is that in step 6, if we reject the null hypothesis and we find that there's a difference, you've got to continue to do things. What do you have to continue to do is you go back to chapter 8 material and calculate some confidence intervals. So we're going to do the example up through this, and then the confidence interval, I'll reference you to a previous video on how to calculate confidence intervals. So let's do an example. The example's from the book. We're going to be looking at certain types of gasoline. So we're going to put the same type of gasoline, three different types of gasoline in the same type of car. A bunch of cars. I've got 1, 2, 3, 4, 5. I've got 15 cars. They're all the same type of car. And I fill them up with the gasoline. I fill up 5 with this type of gasoline from company A, and then company B and company C, or brand A, brand B, brand C, like Exxon, Phillips, and something else, Shell. And I look at the average miles per gallon of these. So what I'm assuming is that type A gas is no different than B and C. So they're all the same, and I'm trying to prove that there's a difference. At least two are different. I set alpha. I calculate my F. How do I calculate my F? I go under Data, Analysis. The very first one, ANOVA single factor, is what you're going to use. You're going to grab the data. I'm going to grab like this. And almost always your data is going to be grouped by columns, which is the default. Labels in the first row. And I'm going to let it generate a new worksheet. And from that, you get something called an Anova Table. You'll always get this Anova Table down at the bottom. The details of all this stuff is not as important. The most important thing are these two numbers. That's what you need to report from. It gives you the summary numbers there. You can see what the averages are, and also measures the variability. But that's used later on. I just want to focus on what is my statistic. In this case, it's an F stat. So this is equal to this number. And the p-value is equal to this number. So now I can move on. Step 5. Since the p-value is less than alpha, you reject the null hypothesis. Step 6. Use confidence intervals to find which are better / different. Okay, once ANOVA tells us that there's a difference, Once Anova tells us that we can reject this null hypothesis and we want to look for differences, then you go back to confidence intervals. You generate a confidence interval. So what does that mean? Is that you go back to the lessons module units, chapter 8 lecture material, and you watch this video on how you use the stock charts to show confidence intervals. Watch that. This data set is the exact same one that we just worked in, and it will show you what you do next to look for differences. Thanks.